Riemann sums part 3. Just a quick reminder that this is our discovery here. This is a little bit of a change for us, but that we said that the limit as the normal partition approaches 0, that is to say that the base of the biggest rectangle is closer and closer to 0, of the summation of f of ci times delta x as I goes from 1 to n is actually the same as the definite integral a to b of f of x dx, and then it's some definition of how we got all of our stuff. And then you guys we started working on the problem, and it blew up all over the place, so we decided that we'd force our way through it. So here's my attempt, and I'm going to get through this with you, and I'm going to show you how I'm going to break this out. So this is what we had. Today we're talking about this. We were talking about the indefinite integral of this whole crappy mess here, plus 4x minus 3 dx. And the first thing that I should have done today was just broken this up into its different pieces. So this is the first piece I want to deal with. I want to deal with this piece right here. This piece right here. And what I'm trying to convince you of is this. Is that this is this. So I'm going to calculate this out, and when I calculated that, just using the same steps that you would, I'll get 1 plus 2i over n, and then this is 3 minus 1 is 2, 2n, so times 2n. Then what I'm going to go ahead and do is I'm going to expand this. So I'm going to expand this out. Try to get this done in under 8 minutes. I'm going to expand this, and that's going to give me the opposite of 1 plus 4i over n plus 4i squared n squared, like that. I think that's what I'm going with right now. And then I'm going to multiply this times this and get this as negative 2n. So this is 2 over n here. Then I'm going to use my summation formulas here and get negative 2n over. So I'm going to use summation formulas. And hopefully you're aware of those. And the summation of 1 is this, plus 4 over n times n plus 1 over 2 plus 4n squared. The summation of I squared is n times n plus 1 times 2n plus 1 all over 6. And hopefully you're remembering all this crap, right? Start to clean this up. 4 over 2, this is 1, this is 2, isn't it? And this n cancel, don't they? I think that's good math, right? This n cancels here, and this cancels here. 2, 4 is like that, isn't it? I hope that's good math. I'm going to bring this stuff in. So I'm going to drag this into here, this into here, this into, whoops, this into there. And that should look like this. Should be negative 2 over n is negative 2, isn't it? Minus 4 over n times n plus 1 over 1. And this times this is negative 4n squared. Isn't that right? And if I go ahead and expand this, I'll get 2n squared plus 3n plus 1 all over 3. Right? I'm hoping like crazy. And this is going to be, I'm just going to keep expanding this crap out. So this negative 2 is this one, negative 2. This is negative 4n over n minus 4 over n. That makes sense? So this is negative 4, isn't it? Negative 4 here. Then I'm going to distribute this into here, 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 and here. Right? Is negative, whoops, sorry, negative 8n squared over 3n squared minus 12n over 3n squared plus, minus 4 over n squared. Holy crap, that's a mess, isn't it? So let's see what that gives us here. That gives us this, that gives us, I'm going to take, right, remember we had this limit thing going on, so I'm going to take the limit here as n goes to infinity. I'm going to take this limit here is -2, -4, -8/3, isn't that right? All these limits go to 0, 0, and 0. Whoops, this one doesn't go to 0. This one goes to -8/3, doesn't it? And let's see if we can make this right. 2 is -6/3, -12/3, isn't that right? Minus 8/3 is equal to -26/3. Keep track of that piece. All right. Now I'm going to do this piece right here. That's part 2. And that's going to look like this. It's going to look like this. It's going to look like of x dx is 4 times 1 plus 2i over n. Summation formulas gives us 4 plus 8 over n times n plus 1 over 2. This cancels this, doesn't it? This goes to 4. This goes to 1, right? Oh, remember, times 2 over n, right? That's what I was going to get lost on. No, and then the summation of this would be 4n, wouldn't it? So we get 8, right? We get 8n. We get 8 plus 4n over n plus 4 over n. And that gives us 12, doesn't it? That gives us 12. That gives us 12. Did I mess up somewhere? 4, 8. Do it again. Stay with me. Just stay with me. It's worth it. Just stay with me. Don't give up. Don't give up. Don't give up. 2n here. Oh, sorry. 2 over n here. 2 over n. This is 8 over n, right? 1 plus 2 over n. I is n times n plus 1 over 2, right? So far, so good. And summate this, this becomes n, doesn't it? And that would give us 8n over n plus 16n over, 16 over n squared, right? Times n squared plus n over 2, which would give us 16n squared over 2n squared, which is 8 plus 8, right? Plus 16n over 2n squared, which is 0. So this gives us 16. So that gives us 16. So far we have -26 thirds plus 16, right? Minus, and let's do the last part here. The last part is this one. I'm going to actually get this done. I cannot believe it. Right, is 1 to 3 of 3, right, times 2 over n. But when we summate that, we get 3n times 2 over n, which is equal to 6n over, which is 6. So we get plus 6. So, oh, and this is minus 6, right? So when we do all that out, we get 4/3. Holy goodness. It actually worked. So hopefully that was good for you.